with normally or let's say Indian society, with environment and economics. So some of the topics which are covered somewhere else, we are not taking up in this session. For example, your population. Population is also a major topic which has been mentioned in GS paper 1 Indian society. So that's why I have not taken up that topic here deliberately. Similarly, your urbanization, agriculture, a lot of things which are common here. So which have already been done somewhere else. So we are not covering. So this will be a roughly 2 hour session. Whatever themes we'll see and discuss, we'll identify which can be important, what has already been asked, what new can come. So we'll see all those of things. I'll be sharing my screen with you guys. Fine. So I am properly audible and the screen is visible. Somebody please confirm.
Yes, so
Fine. So let's move ahead. Now, this is your human and economic geography, the revision mentoring session. Now, see, this is a revision mentoring session in which we cannot cover each and everything just like it is done in the classes. Because for economic and human geography, you might have taken 5, 10 classes, and we'll have just one session to revise all those things. So we'll do whatever things we feel are important and whatever can be useful to you. Now, my advice for majority of you guys are the ones who will be now appearing next year, and most of you must have given prelims, not able to qualify, and you guys are now preparing for next year. And all of you must be going through your MSP program right now. And this is what I am assuming. Is there anybody who is on a different tangent than what we right now discussed? You can tell. And what I'll advise you guys is do not just simply try to take screenshots and build upon a lot of material. Pick up your pen and paper, pick up your class notes of human and economic geography, whatever topic we'll be covering, open that topic, and if you find something new in this session, just add to that class. Or keep it as a revision class. Do not just try to collect notes from everywhere. See, this is my experience. I can tell you, I have given 5 time means, I have given multiple interviews. Whatever you when keep on we keep on collecting material, now it is not used efficiently in the end. बहुत सारी ऐसी चीज होती है which you will collect and they'll stay as it is. वो दोबारा खोल के देखने का टाइम ही नहीं मिलेगा. So your focus should not be on just taking screenshots or collecting material. Focus should be that you take out your notes, whatever topic we are doing. If you find something important, you find something as a value addition, you note it down and move ahead. So your notes should be minimum. You should do maximum revision of those things. That should be the primary aim. Clear? So moving ahead. Now, this is our geography section out of your GS paper 1. Roughly 110 marks from 100 to 115. On average, 110 is the weightage of geography in GS paper 1. That means the weightage is more than your history and society. So, and within geography, largely till now, what was happening? Your physical geography was being asked more. Geomorphology, climatology, oceanography, and physiography of India. Last year, in 2025, they asked more questions, roughly 80 marks from human geography. Now, it does not guarantee that every year they'll ask more from human geography. So the trend might change. But see, human geography is fairly easy as compared to the physical geography. So these are easy marks if you have done it well. So do not always sideline physical, this human and economic geography just by thinking that physical geography is the main thing. You can get good amount of questions from this section also. And these are low hanging fruits. Okay, so this will be today's contours of discussion. We'll have a look at syllabus, we'll analyze some of the PYQs, like how questions are being asked from different topics. Then take 3 broad topics. First is your human geography, within that urbanization, population, and migration, related topics to these. Then natural resources, which will include your mineral resource distribution in India and world. Then energy resources in the form of natural gas and nuclear energy. And why I have taken these particular two, natural gas and nuclear, we'll discuss this. And then the third topic of industries, we'll have a look at industrial clusters and corridors, how they are being developed, how they can be helpful for the economy, and all those things. Clear? So this will be the discussion today. Coming to the syllabus. Now, the UPSC has mentioned this part in your syllabus, in the mains syllabus. Salient features of world's physical geography, distribution of key natural resources across the world, including Indian subcontinent, factors responsible for the location of primary, secondary, tertiary industries, and in the various world and India. Then important geophysical phenomena such as earthquake, tsunami, volcanoes, and how changes are happening in location, features, and all those things, including the flora, fauna, that means your animals, plants, and all those things. Here, this is the syllabus which is mentioned. Within, apart from physical geography, in human and economic geography, you have in human you have demography, urbanization, and census. Largely, basically, all your things related to population, its distribution, urbanization, and all those things. Then in economic geography, you have agriculture, mineral resources, energy resources, industry, and transport communication. Clear? So UPSC sometimes they do not tell you things exactly in detail what all will be coming. So we analyze these things by looking at the previous year questions, that what kind of things they have asked and what can come in future. Moving ahead. Now these are the previous year questions, what they have asked frequently. In human geography, the questions they ask regarding population. They asked questions regarding GIS and remote sensing. Then they asked concepts regarding demographic winter. Then migrants. Why do large cities tend to attract migrants? Then human development. Your human development index is also part of human geography. Okay, so these kind of topics are being asked. In distribution of natural resources, the second larger theme. In this, they have asked about solar energy. They asked about wind energy, mineral oil. These are energy resources. And in natural resources, they will also ask groundwater and fresh water. Now, what you can see in these questions is that the questions are not repeated very frequently. You will not see any repetition in the last 5 years. So this is how we can analyze PYQs and figure out what topics are important for this year. Now, why I have taken up natural gas and nuclear energy? Because you see, they are taking unconventional sources like wind and solar. They already asked. They asked about mineral oil. This year, there is fight between Iran and USA. Now, Ras Laffan gas field was hit by Iranian missiles or drones, and that was the main gas field which supplied natural gas to India. Because of disruption to the Ras Laffan gas field, a lot of Indian industries they could not get natural gas for their processes. So, natural gas was in news for the first time. Indians have faced this kind of crisis specifically related to natural gas. So that's why it becomes important this year, or it might come next year also. So for not only for this year, whatever is not coming this year, it becomes important for next year also. Similarly, your nuclear energy. The government is focusing a lot on nuclear energy. They have brought in new Shakti Act. Their aim is to generate 100 gigawatts of electricity by nuclear energy. Government has brought in schemes regarding small modular reactors. So a lot of efforts are being done for nuclear energy. So that also becomes important in this regard. Yes, this is how we have taken up topics, identified themes which can be important for this year and next year. Next, in industries, they have asked about non-farm primary activities. What can be the other primary activities? Leaving aside the farm activities, the agriculture activities. Then you have rubber production in the country. They asked about rubber production. They asked about mining industries. They asked about IT industries. What are the implications? Why IT industries are developed in large cities? Okay, all those things. So similarly, this year, let's say a lot from last couple of years, you can say a lot of emphasis has been given on industrial corridors. So industrial corridor becomes important rather than asking a specific industry. They may ask about a broader theme like industrial corridor. Okay, and once you know about industrial clusters, corridors, you can write about CUA to at least prepare all the industries separately. Let's say textile industry, your other, let's say your food processing industry, like, and capital goods industry, manufacturing goods industry, all those things you'll have to prepare. But we'll see a broader thing, industrial clusters, both are news may have, they can ask that also. Clear? So moving ahead, these are the 5 rules which you must remember while writing a geography answer. See, whenever you are writing a geography answer, every answer should have geographical keywords. Now, this point is correct for almost all the subjects. You need to have specific keywords for every subject. Clear? For example, in polity, you'll have to write case laws, schedules, amendment acts, Supreme Court judgments, all those things. In geography, you write about plateaus, isotherms, monsoon, biodiversity, relief, drainage, humidity, all these things. Because see, what differentiates a UPSC student from a layman? Now, if you'll ask anybody about what is an ethical conduct, even a rickshaw puller can tell you what is an ethical conduct. कि किसी से उल्टा मत बोलो, अच्छे से बात करो, सबकी हेल्प करो. This is an ethical conduct. But the difference between a layman and us writing an answer is the use of keywords. We write specific things with regarding to any specific issue. That will make our answer look more technical. Clear? Then you'll have to add some visual element almost in every answer. Every geographic answer should have some diagram or map or a flow chart. Any one of them. At least a map becomes the most important in this regard. That almost every of your answers should have map. And by map, I don't mean that you make exact the entire replica of India. You can make rough maps. You can make straight lines like this. And let's say you have to show something on the coastal India or peninsular India. You can make just half of India's map from Gujarat to Bengal. Fine. So got it. You have to practice small maps. Now, if the entire sheet is this much, in this you have to make small maps on the sidelines and label some things over them. Rather than writing everything over it, you make a small map and label on it. Now, whatever you are labeling in maps, do not write it again. So we have to reduce the duplication of things. We'll have to save time while writing answer. We'll have to write less. So if something can be explained through map, why to again write it? So make sure that this type of duplication also does not happen. If you have explained something in diagram, that should not be written again in the answer. Yeah. Then use examples, region-specific examples. The more local examples you give, the better the examiner will give you marks because the examiner will then understand that okay, you are aware of the concept and you can relate it with the physical environment in which you are living. So try giving local examples. Then interlinking of geography with economy, society, environment. Now, interlinking is useful in almost all the papers. One same example you can use in multiple papers. Okay? And similarly, why India and China are fighting? Again, this is a political issue, but you can add geographical angle in that. If geography question comes, why India and China are fighting because of, let's say, your what are the geographical factors which lead to the fight between India and China? Again, you'll write about geographical points, but you can add historical and political points also. So always make sure you have these interlinkages in mind while attending any of the paper, and then focus more on analysis than definition. See, writing definition in introduction is the least preferred form of introduction. Generally, what you'll always try to write dynamic introduction. You'll write something related to it, some analysis, and not just define. Defining can be fine when you don't have anything else in your mind what you can put in. Clear? For example, here deforestation is the clearing of forest. This is just definition. Instead, you write deforestation leads to soil erosion, climate change, loss of biodiversity, etc. Whatever you want to. Fine. So moving ahead, let's come to the first topic of today's discussion. It is regarding in human geography. This is regarding geography and the uneven distribution of population in India. Basically, how geography shapes population distribution in India. Broadly, we know that geography and economic factors they cause India's population to be distributed based upon what kind of conditions are prevailing in a particular area. For example, your plains will be having dense population as compared to the mountains. Clear? So the population distribution is not random. It is directed as a result of environmental opportunities and constraints. What environment offers to you. If the environment offers you better connectivity, there will be dense population. If the environment offers you better agricultural opportunities, there will be dense population at those places. So your urbanization and industry, connectivity, infrastructure, farming, and then the climate also. If the you know that more than 80% of the world's cities, major cities, they are located on the coastal areas. Why? One, the coastal area has better connectivity, more transport, more trade. Two, the coastal areas have moderating effect of climate, the maritime climate. It is neither too hot in summers nor it is too cold in winter. So that's why a lot of people they stay in the coastal areas, and a lot of cities have developed in the coastal areas. Even if you look at India, there are four major cities in India: Delhi, Mumbai, Chennai, and Kolkata. Three of them are coastal cities. Clear? So geography, how if the relief and terrain is conducive, for example, in Indo-Gangetic plains, it is flat plains, so it has high density population. In Himalayas, it is low density. Water, water and climate, if it is favorable, for example, maritime climate of coastal area, Kerala, Tamil Nadu, it has a dense population. In Thar Desert, climate is not conducive, it is extreme, so low density. Similarly, your connectivity, Delhi NCR has better connectivity, so it became capital and a major hub. Whereas the northeastern and hilly states, because of poor connectivity, a lot of people cannot live there. Clear? Moving ahead. Now, apart from relief, topography, climate, we have seen these examples. Water availability is an again important factor. A lot of cities, again, they are on the bank of major rivers. And Delhi, despite it is not being a coastal city, it is on the bank of Yamuna rivers. Clear? So this river water, it provides basically water for drinking, agriculture, settlement, industries, and all those things. Similarly, your natural hazards also determine. It is also an important geographical factor to determine population. Frequent floods and cyclones, landslide, they discourage permanent settlement. Right now, a severe flooding is happening in Assam. So people are migrating from there. And some people will again return back to their native place after the monsoon is over. But few of them will permanently displace from Assam because they will want a better lifestyle, better living conditions where they do not have to migrate every now and then. Right? Similarly, you can if you are aware of the countries like Tuvalu in the South Pacific Ocean, these are small island countries which will be submerged underwater in few years because of climate change and rising sea level. Now, these people will be migrating to Australia permanently. Australia has agreed to give them citizenship. So, forced permanent migration will be happening because of natural hazards. Yeah, so these are some of the geographical factors which determine the distribution of population in our area. Moving ahead, this is some data regarding demography of India. Now, demographic dividend, all of you must be aware that when a large section of population is in the working age group, that is called demographic dividend. Because this demographic dividend is useful for any country. These people, mostly in the young age, they are an asset to a country. They provide a lot of labor to the industries. They do a lot of entrepreneurship work, research and development, which helps a country to grow. Yeah, Bhavna said right. SIDS countries. SIDS countries are small island developing countries, developing states. And these Tuvalu, Tonga, all many of these countries are on the verge of getting submerged underwater. Similarly, a lot of coastal areas of Bangladesh, people are migrating from there also. They are also submerging. So we were discussing about working age population. Look at this working age share of India's population. It will peak at or roughly 69% by 2030, where 69% of the population will be in the age bracket of 15 to 64. That means working age population. Now, this demographic dividend is a positive term where you gain something. Now, this demographic dividend is not a certainty. It is a potential, but not a certainty. If we do not take measures to utilize this demographic dividend, this may convert into demographic catastrophe. So you can use these lines in your answer writing that demographic dividend is a potential, not a certainty. If not utilized well, it can be converted into demographic catastrophe. Because when this much of young population, they are not being provided jobs, they are not given any you can say better lifestyle, they will show their anger. They might go into the wrong path of doing some illegal or criminal activities. So they have to be channelized well. The median age of India is today roughly 27 years, and by 2030 it will be 28.4 years. So that means India is fairly young country. Countries like Japan, they have a median age of around 40. So the people there are so old, and the new birth rate is very low. So average age keeps on increasing in countries like Japan. Fine. So this is some data which you can use somewhere in your answer writing. You can use these in geography, economy, society. So whatever you can use, you use from here. Then the demographic transition. What is demographic transition? See, this is basically a historical shift which every country experiences. When the country moves from high birth rate, stage one of high birth rate and high death rate, to the other stages where they reach to low birth rate and low death rate stage, where the population stabilizes. Now every country goes through this transition stage. India, in till 1920, was in stage one, and stage one is also called pre-industrial. That means underdeveloped stage, pre-industrial, because after industrialization, a country starts developing. So this is pre-industrial stage where in India we were having high birth rate and high death rate. Now, why this high birth and high death rate? Why people used to have so high birth rate? Because at that time, there were not better healthcare facilities. There was no institutional deliveries. Very few hospitals were there. Medicines were not available for diseases. So what used to happen? A lot of children used to die at an early age. So what parent used to think at that time? Let's have five, six children. Even if two, three die, we'll have some to take care of us, or we'll have some to move our family ahead. So this was the mindset at that time. And children's dying because of any disease was kind of, if not acceptable, but normal in the society at that time. So, but right now, people have just one or two kids, and everybody takes care of them very well. Earlier, also people used to take care, but at that time, healthcare facilities were not available. What are available today? The medical advancement, which is today, it was not available at that time. So that's why every country in the beginning has high birth and high death rates. Then they come in the better living conditions, your death rate starts to decline first. Now, birth rate is still high. It will come down with a lag, but right now only death rate has come down. And once people see that the death rate is declining, slowly they'll start reducing the birth rate also. So birth rate reduces in the third stage with a lag. Clear? So second stage is early transition, where India entered into second stage in 1920. And then in third stage, India entered somewhere around in 1970s and 80s. Basically, in 1981 census, so the first time we observed this trend of declining birth rate, and it was a combined effort of government's coercive steps and the education of people. उसी time पे a famous slogan was given, which is called "हम दो हमारे दो." This slogan was to control population. That "हम दो" means husband and wife, and "हमारे दो" means they should have two children, not six, seven as it used to happen in previous generation. So this is called late transition stage. So stage two is early transition, stage three is late transition. And then came the stage four, which is post-industrialization. That means you are into the developed phase. Now, some of the Indian states like Kerala, Tamil Nadu, Goa, Delhi, they are in the stage four, where the death rate is also very low and birth rate is also very low. The TFR, total fertility rate, that means it shows how many child uh, women women having capacity to give birth have over her lifespan. If the TFR, total fertility is 2.1, that means every couple has 2.1 child. It roughly keeps the population stable. Why not 2? Why 2.1? Because some extra deaths might also occur. So 2.1 is the replacement level. That is, the TFR is 2.1, total fertility rate is 2.1. The population will remain same. Two people will replace the previous two people. Okay, but right now in states like Tamil Nadu, Kerala, Goa, Delhi, the TFR is as low as 1.3. That means on average, every couple is having just 1.3 child. So the population will start to decline here. Population will first stabilize, and after a point it will decline because TFR has now gone below the replacement level. New births are not happening. People are getting older, so death rate will start inching up slowly here. Now, countries like Japan, Germany, and some of other Western European nations, they are entering stage five, where their birth rate is still low, but the death rates will start to rise now. because of better healthcare facilities. Their average age has increased to 80, 90 years, but ultimately they'll die around 90, 100. So their death rate will start to increase now, and which will start to they'll start to see population decline. That's why a lot of consumerist people, the capitalist people or the businessmen, they want the population to keep on increasing. For example, Elon Musk talks about having many children. He says that America's population is declining. We have to stabilize it, and that's why every person should have many children. He himself has, I think, 9 children, but he can afford to have. He has lots of money to take care of them. Not every person has. So the inflation, lifestyle inflation is increasing. The cost of living is increasing. That's why people are having less children these days. So these are basically the four stages of demographic transition, and the fifth stage, which is adding up. So you all should be aware of this. Clear? So moving ahead, why is demographic transition not uniform across India? There are a lot of factors why demographic transition of Kerala is different from Bihar. Bihar is in the stage three, whereas Kerala is in the stage four. Because let's say literacy, female literacy and education. Now Kerala has female literacy of 97%, and the TFR there is 1.6. In fact, it has gone now below 1.6. Bihar has female literacy of just 60%, and the TFR is more than 3. So you can see the difference between the two states. And see, it is not only the education. With education comes knowledge and awareness. Women in Kerala, they know, they have knowledge about their reproductive rights. Now, what do you mean by reproductive rights? That women should have the right to decide when to have children, how many to have children, and what should be the gap between those children. Because having consecutive child, it deteriorates the health of women. But if the woman is having enough 3, 4 year gap between two childbirth, so it keeps both the child and woman healthy. Clear? So these are called reproductive rights. They come with education. If the society is educated, they will give these reproductive rights to women. Women will decide how many child and at what gap they will be children. Clear? Then economic development and urbanization. In urban areas, cost of raising children is higher. That's why naturally families tend to have less child. And better health infrastructure and access to that infrastructure will lead to lower, you can say, mortality rates. And if there will be lower mortality rate, people will not have more childs. Now, see what happens. States with poor health infrastructure have higher infant mortality rate, like in Bihar, and parents respond by having more children as an insurance. Now, you understand that, which I told you earlier, that let's have 5, 6 children. Even if one two die, we'll have some with us. So that is a kind of insurance against the mortality rate. So this doesn't happen in states which are having better healthcare infrastructure. Then you have cultural and social factors, son meta preference. Till that time you don't get a son, a lot of families kept on having girl child ultimately when they have at least one son child. That is called son meta preference. This term was given by Economic Survey in 2021. Okay. Then you have government policy effectiveness, differential delivery. Kerala and Tamil Nadu, while they have consistently outperformed in institutional delivery, the institutional delivery, that means the child taking birth in hospital, it is more than 99%. Whereas in UP, Bihar, or in the, let's say, the rural areas of Bihar, it is 60, 70, 80%. Okay. And so it is, again, it gets directly linked with the education and healthcare infrastructure point. This policy gap directly explains why demographic transition is faster in the south. So these are some of the factors why India is having different, or you can say why India is having dichotomy in the demographic transition between different areas or different states. Everything clear till now? All of you, are we on the same page? If you have any doubt, you can ask me. Fine. So we'll move to the next topic, that is migration. Now, again, migration refers to the movement of people, fairly simple. And this can be intra-country, intrastate, or within different interstate or inter-country, anything. Now, what are the major causes of migration? See, the single most important reason for migration is your employment. Yeah, employment. So if you see the different causes here, demographic factors, aging population creates labor demand in developed countries. Now, when labor demand is created in developed countries, um, see, if you take, let's understand everything with example. In Japan, in Germany, the People are getting older. They do not have the capacity to work in factories. They need somebody to sustain their factories or their economy. They need doctors and nurses of young age to take care of the geriatric care, or let's say the older people. So they will drive pull-based inflation, that they demand people. So they create a pull demand. Clear? Similarly, you have economic factors like migration for jobs, better income, better standard of living. Somebody migrating from India to America in the search of better job, better lifestyle, higher income. This is the commercial factor, which is the main factor for driving people. Same migration, the economic factor is also responsible for rural to urban migration. Then you have environmental factors triggered by environment, as you see in the case of Tuvalu. Then you have political factors, sometimes due to conflict. For example, civil wars, partition. A lot of people, one of the biggest mass migration happened in 1947 in South Asia, where people migrate from Pakistan to India and India to Pakistan because of political factor, the partition of country. Similarly, because of conflict zones, civil wars, coup, a change of government, people migrate. Rohingyas migrating from Myanmar to Bangladesh and India because of political factor. The people from Libya crossing the Mediterranean Sea and migrating to Europe. The people from Syria migrating to Eastern Europe. All these are political factors for migration, basically to um, make put themselves in safer situation. And then the social factors driven by family ties. For example, marriage in India is a major factor for female migration. Almost every woman in India, they migrate because of marriage to a new home. Clear? And then we'll see why some of the large cities they attract more migrants than smaller cities. Again, the points are largely same. The larger cities have better employment opportunities, better income, better education and healthcare infrastructure, better connectivity, better trade transport avenues. So they have higher social and economic mobility. What do you mean by social mobility? Now, economic mobility is clear that you earn higher income in urban areas, you reach to a different economic level. Social mobility means that in rural India, till now, caste system is prevalent a lot there. Okay, so people they are too much into caste system. Even if somebody earns good amount of money, he is still seen with the lens that he belongs to that particular caste. And in a lot of caste, even today, I'll give you an example. In some rural villages of, let's say, UP, Bihar, the lower caste people, they are not allowed to sit on horse during their marriage. The groom is not allowed to sit over horse during the possession of his marriage in front of higher caste people's house. So when they come in front of higher caste people's house, they have to come down from the horse and then cross it. So the caste system is still prevalent in rural India. But when you come to the urban area, now you are not aware who is your neighbor. Your neighbor and you might be from completely different caste. You might be having similar kind of jobs and having a similar lifestyle. And nobody gives a damn about caste system in urban areas. Mostly, there are isolated cases, but mostly it doesn't happen. This is called social mobility. That you move from one level to other, and you have better exposure to different things. You have better respect and moving to better society overall. So this is also one factor of moving from rural to urban area or to a larger city for a lot of people. Now, what is the impact of climate change on migration? Climate change adds another dimension to migration. That what climate change does is it increase the extreme weather events. For example, the number of cyclones coming has increased because of climate change, because of higher sea surface temperature. More energy is provided in the form of latent heat to the cyclones, and they come with better in higher intensity. Similarly, your rainfall, because of climate change, the rainfall total amount of rainfall has not changed, but what has changed is the concentration of rainfall. Earlier, let's say 100 centimeter of rainfall used to happen in a span of 2 months. 100 centimeter rainfall. The same 100 centimeter rainfall, instead of 2 months, now it is falling down in just, let's say, half a month, or 1 month. So the time duration has been reduced, which has intensified these extreme weather events. Clear? Similarly, your sea level rise because of climate change induced migration, agriculture disruption. A good example of agriculture disruption is your the Vidarbha and Marathwada region in Maharashtra. Frequently, this whether Marathwada, Rayalaseema, this region face severe drought conditions, and because of this drought and failure in agriculture, a lot of people migrate out of that region in in search of finding better employment opportunities somewhere else. And with climate change, this drought and flood, these frequencies are changing. Similarly, you have water scarcity, reduced water availability due to droughts and changing precipitation pattern. When this precipitation pattern changes, when intensified rainfalls happen in a shorter period of time, what happens? The water does not get infiltrated into ground. If rainfall happens slowly over a longer period of time, water gets infiltrated into soil. It reaches the aquifers, recharges the groundwater, and all this is skipped if the intensity of rainfall is higher and water just runs away very quickly. Clear? So these are some of the impact of climate change on migration, how climate change is impacting migration. Now, with this, we have come to end to first topic of today's discussion. Basically, we have discussed broadly human geography, in which we included your population, demography, migration, these factors. Now, let's come to the climate, your natural resources. If you have any doubt, you may ask. If anybody has any kind of doubt. Fine. So let's move ahead. Now, what are minerals? Basically, minerals is a natural substance of organic or inorganic origin with definite chemical and physical properties. Now, definite physical chemical property is an important term here because, see, everything has some kind of, you can say, elements and properties in it. But there are certain minerals which are useful for us. Because of their properties, they are classified. The minerals can be metallic minerals, non-metallic minerals, and fuel resources. Now, within metallic also, you have different types. One major property of these metallic minerals is that they are good conductors of heat and electricity. That means they allow heat and electricity to pass through them at a good rate. And similarly, then for non-metallic minerals, one important property is that they are bad conductors of heat and electricity. They are brittle and they break when stuck. That means they are not as flexible. For example, the bakelite, or you can say silicon, plastic, all these are non-metallic minerals. They do not allow heat and electricity to pass through them easily. Clear? So, and based upon the iron content in metallic minerals, they are further classified into ferrous and non-ferrous. Ferrous means containing iron. Non-ferrous means that they do not have any proportion of iron in them. For example, copper is a metallic mineral. It is a metal. It is non-ferrous, non-iron based. Clear? And in non-metallic, you have industrial minerals like limestone, dolomite, gypsum. You have heat-resistant material like asbestos and mica. You have chemical minerals like sulfur, phosphate, potash, which are also used as fertilizers. Then you have ornamental minerals like marble, granite. These ornamental minerals, or diamond is also ornamental mineral. They are used granite, marble in construction as almost in every home they are being used. Then comes the fuel resources, those with electric and nuclear power. These can be fossil fuels and other atomic minerals. Fossil fuel can be your coal, petroleum, natural gas, and atomic minerals like uranium, thorium, zircon, basically which produce nuclear energy. Clear, this is the broader classification of minerals. Moving ahead, mineral distribution across the world. Now, how these minerals are distributed across the world. Now, iron ore, it is a foundational mineral. It becomes the basis of all the other industries, the development of all the other industries. Now, basically this largest deposits of iron, they are found in the ancient sedimentary rock formation. Within the sedimentary rocks, these iron ore deposits are found. You take out these iron ores, you purify them, separate the impurities with the iron, and your iron is created. And on further processes, your steel and other cast irons, they are then produced. Now, which are the largest top producers of iron ore in the world? Australia, Brazil, China, and India. See, you can see all the maps. India is only among the largest producers in iron ore. In rest, all the major minerals, we are not among the top producers. So, some bit we produce on our own, and some we import from other countries. Similarly, if you look at bauxite, bauxite is an ore of aluminium. Bauxite is an ore which you extract from ground, then remove the impurities and aluminium aside, and aluminium is taken out of bauxite. Again, it is found in sedimentary rock formations and Australia. is again the largest producer, not just for iron, but for bauxite also. Clear. Similarly, then copper. Copper is an excellent conductor of electricity. So mostly all the electrical wires are made up of copper, and the deposits are often associated with volcanic and tectonic activity along the plate boundaries. Yeah. And again, Chile, Peru, Democratic Republic of Congo, China, these are the major producers. So your manganese, manganese is a critical alloy which helps strengthen the steel. So when it is in certain proportion in amount, it is added to the steel, it increases the strength of steel. So that's why the railway tracks are created with this kind of alloy when mixing iron with this manganese. Again, it is found in sedimentary and metamorphic rocks, and South Africa is the largest producer. When it comes to diamond, it is the hardest known substance present on the earth. Diamond is not just used in jewelry, diamond is also used in a lot of industrial applications. Diamond is used to cut different other metals or non-metals, whatever. Okay, you have a lot of diamond cutters. These diamonds they are found in ancient stable continental crust cratons with volcanic pipes called kimberlites. Basically, these are found in old, let's say, these are form of carbon. Carbon over time undergoing temperature pressure differences, it converts into diamond. These are found in old veins where earlier volcanic magma used to come out from those pipes or veins, which are now dormant because when volcano is coming out from there, it increases the temperature pressure, which converts the carbon into this diamond. Okay? So basically, coal and diamond, they are from the same family. The same coal, when it might undergo under different temperature, pressure, stress, it might convert into diamond. This is the same thing which will happen with most of you guys. Right now, you guys are coal. A lot of pressure is there on you to study, to perform, to put in hard work. And finally, in the end, you'll come out becoming a diamond by getting the selection or by becoming a better human being. We'll not just base our final selection as the criteria to become a diamond. By learning things, by becoming a better human, by becoming more intellectual, by going into any field in the for your jobs, you will become better if you study well. Similarly, for gold, used in jewelry, used in finance by a lot of central banks, keep gold as a forex reserve, and in other electronic equipments. A lot of gold, silver, platinum, they are used in electronic equipments also, and these are found in wide variety of geological settings like quartz veins and riverbeds. Riverbeds are basically floors of rivers. On floors of river, you find a lot of gold. And what are quartz veins? Can anybody explain what are quartz veins? Anybody who is aware of what are quartz veins? At least say yes or no. No, sunglasses. No, okay.
No, sir.
So basically, okay. So basically, what are quartz veins? See, there are certain in within the rocks, sedimentary rocks or the igneous rocks, there are certain cracks developed in between. Now, what happens when the water deep within the earth, water gets heated a lot, it mixes a lot of minerals within it. When it water mixes minerals and water starts moving up close to the crust, when water keeps on coming high, temperature keeps on reducing. So the minerals which water has mixed with it, at certain point they get solidified. So let's say in 500 kilometers under the earth, let's say there are some gold, you can say gold rocks which are dissolved in water now. When it is coming up, let's say it came right at 200 kilometers distance from the crust, it has now temperature has been reduced and gold gets solidified and gets deposited there. Water further evaporates or solid or whatever happens, but that mineral which is deposited or mixed into the water that gets solidified. So these are called quartz veins, the cracks in between where water in the dissolved form has brought that mineral and that mineral has then solidified there. Yeah. Okay. So moving ahead, and China is the largest producer of gold along with Australia. So you can see China almost in every, except diamond, China is almost in every major mineral. They are among the top four producers. You can see Australia also. Now, these are also one of the reasons why China is becoming an economic giant. Entire world is now getting dependent upon China for major minerals, critical minerals, rare earth elements. So China has put in all a lot of hard work in extraction of these basic minerals, which became the foundation for developing other industries. Moving ahead, you can also show on the map how different areas have, you can say, some kind of mineral resources. For example, you can see here a lot of copper deposits are found on the west coast of South America. In India, you can see coal deposits, iron ore deposits, and your bauxite ores. This bar represents bauxite, and this skin color and black color represents coal and iron ore. So you can also show like this. In Australia, you have a lot of minerals. Okay, moving ahead. Now, mineral resources in India. See, in India, we broadly have five major regions where mineral resources are found. Apart from these five, there are other areas also where minerals are found. But these five are the major belts where minerals are found. First is the northern belt or northeastern belt. Broadly, it is called northeastern belt, or it is also called Chota Nagpur belt because it is at the Chota Nagpur plateau. Is the core region here, and this belt is also called the mineral heart of India, because almost all the major minerals are found in abundant quantity in this place. Where iron, coal, and other minerals. That's it. Copper is also found there. Okay, then manganese also found there. You have mica also. So this is called the mineral heart of India, Chota Nagpur belt, or the northern or northeastern belt. All are same names for it. Yeah, ancient crystalline rocks primarily from Precambrian era. And you have a lot of iron ore, manganese, bauxite, coal in the Chota Nagpur Plateau. States कौन सी है? Jharkhand is the primary state, and along with this, it is also spread in Odisha, West Bengal, and Chhattisgarh in the surrounding regions. Then you have central belt, having Deccan Traps and Gondwana. This is central belt. Both these. There is upper central belt, the lower central belt. Both these. They have coal, iron ore, manganese, and they constitute areas of Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, and some parts of Maharashtra also. Then you have southeastern region, again among the sedimentary and volcanic rocks. This is the southern or southeastern region, the one major belt, having a lot of iron ore, manganese, bauxite, coal. Yeah. And then you have southwestern in the Dharwad rock system. Again, you have this. This is your southwestern mineral belt. This diagram has been taken from NCRT. Yeah, this is southwestern belt. Most of you must have either seen the movie KGF or heard about that movie. KGF was a very famous KGF 1, KGF 2, second part has also come. Now, KGF was Kolar Goldfields. Now, those Kolar Goldfields, they are situated in this region, in southwestern mineral belt, Kolar Goldfield. Yeah. Kolar is the region's name, and that mine was famous for gold extraction or gold mining. So that's a Kolar Goldfield. And then you have northwestern region. This is the northwestern region, the belt from Gujarat to Rajasthan. This is famous for sandstone, granite, marble, gypsum, fulham. Now look at this. These are mostly your non-metallic minerals found here in Rajasthan and Gujarat. Your Khetri mine for copper is very famous here. Khetri mine for copper. You have Makrana marble mines, very famous here. Makrana marble mines. A lot of marble goes from Makrana to entire country. Yeah, so these are five major mineral belts of India. Apart from this, this region is also famous for a lot of oil and you can say gas exploration. The Assam and Arunachal region, oil and gas exploration. ठीक है, Dibrugarh oil fields are famous for extraction of oil and gas here. But five major regions, you should be able to highlight them on a map. So practice this map. पांच रीजन बनाने एग्जैक्टली बनाने ब्रॉड आइडिया ब्रॉड लेबलिंग हो जाए so you can name five of them where they are situated. Your northeastern or Chotanagpur mineral belt, your central Indian mineral belt, southern mineral belt, southwestern mineral belt, and northwestern mineral belt. Yeah. Moving ahead. Now within this, you must be aware of the critical minerals. Critical minerals is an important term at least for this and next year. Why? Because they were in news again and again. Just the region or with each mineral we do have to do practice. No, I'll not say do with each mineral. What you can do in this map, you can basically give some examples. For example, as I've told you, here you have Khitri copper mines, so you should know this name. You have Makrana marbles. You have Singhbum mines. You have Jalia coal field here. So you must know these names. You have Kolar Goldfield here. You have Baba Budan Hills here. Baba Budan Mining Hills here. Okay. So like this, you must know the names, some names, so that for every region, whenever you are writing, you can give some example with every point. So कुछ कुछ example you can easily remember. Okay, जी. So critical minerals, what are these critical minerals? A mineral is labeled as critical when the risk of supply shortage and associated impact on the economy is relatively higher than the other raw materials. Basically, if these critical minerals are not supplied to us, the country may come to a standstill or the industries may face disruption. Those minerals are called critical minerals, which are used almost in every industry and they are not easily replaceable or they do not have a close substitute. So those are called critical minerals. Okay, basically they have an economic importance in the country and there is a supply risk also, which makes it a critical mineral. So India has identified 30 such critical minerals essential for its economic growth and technological development. Some of these are antimony, beryllium, cobalt, copper, graphite, etc. Among these, India has sufficient reserves for copper, graphite, rare earth, etc. However, it is dependent upon import of lithium, cobalt, germanium, indium, and selenium, etc. Now, lithium is a major component for battery manufacturing. If India has to transform to a clean mobility solution, electric vehicles, we require a lot of lithium. But do we have so many lithium reserves? No, we are still dependent upon the import of a lot of lithium. We have small reserves we found of lithium in Jammu and Kashmir, but they are not big enough to sustain the entire demand of our country. Also, we do not have the capabilities to extract and refine or process these raw materials also very well. Fine. So economic importance is sometimes determined by these points, like how disruptive it can be. What is the sustainability index without these minerals? And but largely these are of not so much of use to us, so we'll skip them. Then comes the global criteria, global critical mineral production. Who are the major players in global critical mineral production? Because see, this data is some 3 4 years old, but it is still relevant today. Like in germanium, majority 96% of it is produced by China, palladium by Russia, strontium by Spain, cesium by Canada, similarly beryllium by USA. Now, lithium, 54% of lithium is produced by Australia. Although Chile has the largest lithium reserves in the world, but Australia produces largest lithium because of the technology to extract it. For India, the local production of lithium is just 0.003%. Even if it would have increased by now in last 3 4 years, it would have still be less than 0.1%. So now you understand how we are dependent on other countries for lithium. That's why we are also taking some steps in this regard. We'll see them in other slides. So how can India secure the supply chain of critical minerals? What step India needs to take? Broadly, two steps. One is accelerate domestic mining. So India is auctioning critical mineral blocks like lithium in Jammu Kashmir, rare earth in Karnataka and Rajasthan to attract both public and private investment in exploration and extraction. So first thing we have to do, we have to accelerate domestic mining by involving efficient players, let's say private players. So these sectors earlier, which were reserved for public sector, now are being opened for private sector. Why? Because private players are more efficient when it comes to any kind of job. So they can do better mining. So they are now being given these opportunities. Similarly, you have bilateral and multilateral agreements, secure long-term supply chain joint ventures and diplomatic engagement with resource-rich countries like Australia, Argentina, Chile, and African nations. Basically, we need to diversify our raw material sources. Now, a lot of countries, let's say, take an example of America, they were dependent on China for rare earth elements. These rare earth elements are then used to make, for example, permanent magnets. These magnets are used in electric vehicles, renewable technologies like solar cells, solar manufacturing, space technology, defense manufacturing, automobile manufacturing. Everywhere these magnets are used, which are made up of rare earth elements. But America is completely dependent upon China for this. That's why Donald Trump is not able to bully China. Even if they try to put sanctions or something else on China, China says, okay. Suddenly, Xi Jinping, one day he said that we are stopping any export of rare earth elements to USA. So China has a leverage over USA right now because they have the critical minerals with them. So India does not want to come in a similar situation. That's why we are diversifying our raw material sources. For example, the Khanij Videsh India Limited, which is a government PSU, had a joint venture. In a joint venture, is acquiring stakes in lithium and cobalt mines in Australia and Argentina to secure steady supply. If we'll have an agreement with these countries for long term, we can have a reliable supply source. Understood? And what are the other initiatives taken by the government to secure these critical minerals? First is the National Critical Mineral Mission of 2025, launched to basically secure India's clean energy future by availability of 30 identified critical minerals, which are vital for solar, wind, electric vehicles, and battery storage. In battery storage, also we require a lot of lithium. And multiple, basically we have identified these minerals, we are securing their raw material by anything. Under this national critical mineral mission, we have more mining options also, we have joint agreement options also with other countries. Then government amended the Mines and Minerals Act 1967, where they ended the central government, enabled the central government to auction 24 critical minerals mining. So they'll auction them and whosoever wants can bid for them. And more than 100 blocks are set for auction. Increased exploration is being seen. The Geological Survey of India, they have taken off 195 projects in last few years, and offshore exploration for polymetallic nodules is also being scaled up. Now, can anybody tell me quickly in which sea or ocean we are exploring polymetallic nodules? We means India is exploring polymetallic nodules. Let's give you a hint in Indian Ocean. Where specifically in Indian Ocean we are exploring polymetallic nodules? Quickly, anybody have any idea?
So near Arabian Sea area, if I'm not wrong.
Navi Mumbai, no. Navi Mumbai is a land area. We are exploring in ocean. Um, a girl was saying something online. Can you repeat it?
I'm not sure, but near Arabian Sea area.
No, Arabian Sea is again is not the right answer. Bay of Bengal, River. Hey Sai, you are giving such a good guess. Let's speak both Bay of Bengal and Arabian Sea. So you are taking a tukka. कहीं तो लगेगा. No,
Near
it's a
Sri Lanka.
southern Indian Ocean. It is in southern Indian Ocean. When you go down from, let's say, Chennai, you go past Sri Lanka and further you go south in the southern hemisphere of Indian Ocean. There we are exploring India along with China. We are exploring the polymetallic nodules. What are these polymetallic nodules? These are basically mineral or metallic mineral balls which are lying on the seafloor. Now, they have a lot of critical minerals in them, metallic minerals. Their extraction is tough. Now, it takes a lot of resources to extract them from the seabed, bring them to the mainland, process them, and use them in industry. If we get a good technology to do this, they will be of extremely useful. But we do not have enough technology right now. We are having floating ships, floating laboratories there, which are constantly sending robots down, which are picking up these minerals and bringing them. Because these are very deep seas, and a lot of unknown biodiversity is down there. We can also not take the risk of disrupting the unknown biodiversity there. I'll give you one example. For extraction of anything down there, we'll have to put in light there. But a lot of marine bioorganisms or which are living species down in the sea at, let's say, 3 4 thousand meter depth, they are not adapted to light. They are adapted to darkness. If the light goes there in that region, that light will disrupt their life. Then while extracting a lot of soil disruption, seafloor disruption, vibration, noise pollution. Then you can say a lot of waste will also be thrown in the seas also. A lot of pollution will be created. So a lot of effects are there. And a lot of money is also required in this process. But these are very good sources of critical minerals, polymetallic nodules. They have a lot of manganese, they have cobalt, they have nickel, they have copper. A lot of these are there. Gold is also there. Then what are the other steps? Khanij Videsh India Limited, Kabul. It is a key agency for overseas asset acquisition. We have seen they are doing agreement with Australia, Argentina. Then India Australia Critical Mineral Partnership. Again, India has in partnership with Australia, where Australia will supply a lot of these critical minerals as raw material. And then government has taken a lot of supportive ecosystem steps like new exploration licenses are being given to private players. There are incentives for private players. Secondary source recovery. A lot of these critical minerals they are being captured from waste, like from fly ash, tailing, and the tailing is something like when you burn fuel in your car from the car's tailpipe, gases are coming out. If you tap resources from there, that is called tailing. And then a lot of skill development is happening. People in this sector, mining sector, and fast track approvals are given to the auctions, or you can say the mining processes. Any other country doing mining in deep sea? Yes, a lot of countries are doing. Um, if anything of such scale is happening, we cannot ignore America. America is always there ahead in these kind of works. China is doing this. Australia is doing this. I think Peru and Chile are also doing this because there is a Clarion-Clipperton zone in southern Pacific Ocean. There, that region has the highest concentration of polymetallic nodules. So Peru, Chile are also doing this. America is also doing it there. So a lot of countries are doing. Basically, they have to take permission from International Seabed Authority. The International Seabed Authority gives the permission for any country to explore these minerals, and it is given on a condition that whatever you will extract, whatever commercially, once you start extracting, then the benefit will be shared with other countries also. Then any technology transfer between India to any other country. From India to another country, no. India require technology. We will take it from other countries. We are not so much technologically advanced that we will provide technology to other. Whatever countries are doing exploration in this field, they are ahead of India. So right now, no such technology transformation is happening. I think in Indian Ocean, India and China together they are doing this work, but nothing concrete has been done till now by any country. Okay, I hope you understood it. Moving ahead. Now let's have a look at the rare earth elements within your critical minerals. What are rare earth elements? See, these comprise the 17 chemical metals like scandium, yttrium, and 15 lanthanides. These are basically elements which are on a specific portion of periodic table. Why they are called rare? They are not rare in the presence on Earth. They are abundantly available in the Earth's crust, but they are rarely found in concentrated form. That means, yes, they are abundantly available, but they are scattered in different places, which makes their, you can say, mining economically unviable or difficult. Let's say, if not unviable, at least difficult. So if you have a lot of concentration of critical minerals as or rare earth elements at one place, you can extract them once and then process them. But you have some here, some here in different places. Their extraction becomes difficult. Their refining and processing becomes difficult. That's why these are called rare earth elements. So again, remember the word rare does not here mean that they are rarely present on Earth. They are abundantly present, but their extraction and processing is tough. What are their technologies or applications? They are used in green tech like electric vehicles, motors, wind turbines. They are used in electronics like smartphones, cameras, laptops. Everywhere they are used. They are used in aerospace and defense. They're used in night vision goggles, guidance systems, jet engines. And in India's context, what are the different challenges? For example, reserves. India hold was fifth largest reserves of rare earth elements. But again, despite having fifth largest reserves, we are almost entirely dependent upon imports for them because we do not have the processing capabilities. Then vulnerability, India possesses light rare earth elements but lack extractable heavy rare earth elements. That means most of our reserves they are dispersed. They are not even in small quantities. They are not concentrated in some places. So it again makes it tough to extract. And processing hurdles, monazite sand, which contains rare earth elements, and their extraction involves radioactive thorium, making processing capital intensive, state controlled, and technologically complex because they have radioactive elements also along with them. Then geopolitics, China holds near monopoly and global mining and refining capacity. China can dominate terms of reference of trade and other kind of relations with other countries. And now the Arctic region, when the ice is melting over Arctic because of global warming and rising temperature, the new area which is being exposed in Arctic, that area is containing a lot of rare earth elements. And when the new area is getting exposed, now countries will start fighting against each other for that control of that area because that area is rich in so many minerals. Your metallic, non-metallic, rare earth elements, critical elements, all are present in Arctic. So once the ice melting will happen in those regions, Russia, USA, Canada, China, European countries, they'll start fighting to gain control over that region. That's why you must also know that one element of Belt and Road Initiative of China, they have a route from north of Asia. When the Arctic ice melts, they can move ships from that region also. Yeah. So Arctic is emerging as a strategic frontier because retreating ice is exposing mineral deposits, including rare earth. Clear? Now, what is the India's again? India's measures for rare earth elements, just like your critical elements. We have rare earth permanent magnets manufacturing scheme. We have specific rare earth permanent magnets manufacturing scheme. These magnets are used in, as I told you, in automobiles, wind turbines, aerospace engines, etc. Government has made some dedicated rare earth corridors in four states: Odisha, Andhra Pradesh, Tamil Nadu, and Kerala. These four states has been designated as rare earth corridors, where focus will be on mining of rare earth, processing, R&D, and manufacturing. Then strong resource base. We have a lot of deposits, but we need to work on its processing. Reducing import dependence. Currently, 60 to 80% of the value, and by volume, 85 to 90% is imported from China. And demand is expected to double. Why? Because the consumption of electric vehicles, batteries, smartphones, connected devices, they are being increased. So it will require more and more of the rare earth elements. Yeah. Then changes in the Minerals and Mining Act amendments and other organizations like CABIL, which are doing international asset acquisitions, they will further help. And you have global integration partnership with Australia, Argentina, Africa, then partnership in MSP and IPF. These MSP and IPF, they are basically supply chain programs led by USA and European countries, in which specifically USA, they want to diversify the supply chain for these rare earth elements and critical elements. Basically, USA has understood that relying completely on China will be strategically dangerous for them. So now they are bringing in like-minded countries and they are trying to move away from China as a source of raw material for these elements. Clear? So these programs, India is also a participant in these programs. Now, coming to the third type of natural resources, which is your energy resources. In energy resources, you have conventional and non-conventional. You all must be aware coal, petrol, energy, they conventional, non-conventional include your most of the renewables. And this is some data which can be used in mains answer writing. We are the third largest producer of energy resources. We are the third largest consumer also. Let's say after US and China, we are the third largest consumer. The installed capacity of electricity generation is fifth highest. And then the per capita consumption in India, it is roughly one third of the world's average. That means we are still a developing country. Our per capita electricity consumption is one third of the world. And if you compare it to countries like USA, they have 10 times more energy consumption than India because we rely a lot on labor work. A good example is that most of the utensils, kitchen utensils in our homes, they are cleaned by hand, either by our mothers or we ourselves do it or our maids do it or any kind of house help does this. But in most of the houses in America, they are done by dishwashers. The dishwasher again require a lot of electricity. So likewise, for car washing, we have people here to wash car. There the cars are washed by machines. So the per capita energy consumption is very high in developed world. In India, the same trend will follow in future. So as of June 2026, it is the latest data. The renewable energy capacity of India is 288 gigawatts. 288 gigawatt. It is the installed capacity. One more thing, always remember there is a difference between installed capacity of electricity and power generation capacity. Installed capacity does not mean exactly say all the capacity is used to generate power. For example, I might have 162 gigawatt of solar power installed capacity. But out of this 162 gigawatt potential, I'm just developing 100 gigawatts of electricity. Rest 60 is lying vacant. So installed capacity and generation capacity are different things. If you can see here, out of the total installed capacity of 521 gigawatt, roughly 27% is solar. The coal is just 43%. But when it will come to electricity generation, the coal with the capacity of 43%, it is entirely being used. But the renewables, they are not entirely being used. Solar is 27% capacity. But if you see in the next slide, from solar, we are just producing 10% of electricity. Installed capacity is 27%. We are producing just 10%. And coal, which was having installed capacity of 47%, they are producing 67% of the total electricity in India. Clear? So that means whatever electric cars or electric two-wheelers we are running these days, they get power from coal-based electricity. So where is green technology in this? We opted for electric vehicles just to make sure that the environment is clean, but the same electricity which is running these electric vehicles, it is powered by coal, and coal is a polluting element. So we need to further utilize these renewable energies. We have to better take use of them. Yeah. So these are different latest capacities of solar, let's say 162 watt, wind 57 gigawatt, biopower roughly 12, hydro 57, and nuclear 8.8 gigawatt. This nuclear capacity, the target is to increase from 8.8 to 100 gigawatts by 2047. These are the latest data. You can note them down, and they can be used anywhere in any kind of question. And within this, we have five Panchamrit targets. These Panchamrit targets are the nationally determined contributions which India has pledged voluntary to take these steps. Now, under the Paris Agreement, every country has to take these voluntary pledges that what you will do as a country to reduce the global warming and climate change. So, India has taken five pledges. First is reach a non-fossil fuel energy capacity of 500 gigawatts. Right now, we are having roughly 300 gigawatts. That capacity has to be increased to 500 by 2030. Then fulfill at least 50% of the energy required via renewable. Right now, 67% is coming from coal. This has to be reduced. 50% should come from renewable generation also. Then reduce CO2 emission by 1 billion tons by 2030, reduce carbon emission intensity basically by 45% by 2030, and achieve net zero. That means whatever emissions we are having, more than that, we are capturing and storing emissions. So net zero emission by 2070. This is India's target, five Panchamrit targets of India. Now moving ahead to natural gas as the energy resource. Within natural gas, as I've already told you, why we have taken natural gas as a topic, because it was in use. Our supplies of natural gas were disrupted because of Iran-Israel war, and it is important. The primary constituents of natural gas are methane and ethane. These are the two primary constituents. However, in small amount, propane, butane, pentane, and hexane are also present. But अगर prelims में कभी आपका क्वेश्चन आता है, what constitutes natural gas? The answer will be methane and ethane. Now, Russia's reserves account for almost a quarter of total global gas reserves. That means 25% of the gas reserves are in Russia. Similar kind of gas reserves are also present in Middle East. Now, a lot of people they think that like all the Middle Eastern countries, Qatar is also having a lot of oil reserves, but this is wrong. Qatar is majorly dependent upon natural gas. So Qatar supplies natural gas to different countries. They export, for example, they export natural gas to India also, and that's how they earn money. They do not have oil deposits. So the biggest refinery of Qatar was Ras Laffan. That Ras Laffan gas field was hit by Iran, and it stopped the production of natural gas, and that's why it disrupted Indian industries. So the natural gas, it currently contributes 6.2% in India's energy basket. That means out of all the electricity produced in India, 6.2 is by natural gas. The aim is to increase the share of natural gas to 15% because natural gas is a cleaner fuel as compared to coal and crude oil. It is a cleaner fuel. It does not pollute environment too much. And if you look at the natural gas reserves in India, where they are eastern offshore, that means away from the coast on the oceans. Eastern offshore, you have a lot of gas reserves. How these gas reserves are formed? Just like how crude oil is formed, they are also formed similarly by organic, you can say, um, organic decomposition of forests, old forests which have been buried under the earth. And on the same first, oil is found, and in the same fields under the ground. So in the upper spaces, the gas gets trapped. Gas is also found in similar manner. So from the same fields from where oil is extracted, in some adjoining fields, you have gas also. So in western offshore, let's say Bombay high and adjoining areas, you have 29-30% of natural gas reserves of India there also. There are a lot of gas reserves in Assam also, in West Bengal also, in Rajasthan. That means these are the areas which were at some point they were submerged under the sea. Rajasthan was also submerged under the sea at one point of time. And if you look at the larger geological time scale in geography, thousands and millions of years is not a bigger time scale. These are smaller time scales. So millions of years ago, Rajasthan was under sea. So that's why they have developed these natural gas reserves there. They have developed some oil reserves also there. In Bikaner, we have oil reserves. Now, what is India's plan for a gas-based economy? What is India doing? So we are basically actively transitioning towards gas-based economy to reduce import dependence on crude oil and enhance energy security. And also, natural gas is a cleaner fuel. Objective is to reduce import dependence. We import majority of the oil from other countries. Although we import 50% of gas also, but at least 50% is domestically produced. Increase the share of natural gas up to 15% in energy generation. Diversify energy sources, moving away from coal, which is a polluting source. Okay, and what are the hurdles in expanding India's natural gas sector? Again, expensive imports. India import nearly half of its gas, making it vulnerable to volatile global prices. Now, what happened in this crisis? The households, whatever domestic gas was being produced, that domestic gas was directed towards household in the form of PNG gas, LPG gas, or cars. The commercial gas, mostly it is coming from imports, that was stopped. So factories stopped, which were dependent upon natural gas. There is low domestic production in India. There are lack of pipelines connecting the areas of production to the areas of consumption. Clear? So these are some of the areas which are having gas reserves. Like this is the western offshore, which is 30% of the gas reserves. Okay, near Bombay and other areas. Then this area is the eastern offshore, along with you have Assam, Tripura. Here also you have gas reserves. Clear? This is given by GAIL, Gas Authority of India Limited, which is a Mahanagar PSU of government. Then what are the other challenges posed by import of natural gas to India, which has been highlighted in the current geopolitical crisis? The Hormuz Strait and the Red Sea vulnerability. Iran stopped the movement of ships from Hormuz, and the Houthi rebellions, they are saying that we'll stop the movement of ships from Red Sea. Now, it will expose again countries like India, which are dependent upon import. Then sanctions blocking cheaper sources. Now, India can import a lot of natural gas from Russia also, from Iran, but because of sanctions on Russia and Iran by the USA, we could not import. So again, these sanctions have an indirect impact on India also. Then dollar dependency and payment risk. Most of these trade they happen in dollar terms. So this dollar transactions they go through a SWIFT system. This SWIFT is a financial system which clears these transactions. Again, it is controlled by America. So we are dependent upon dollar for all this. We have to again diversify here. We have to do more bilateral trade in rupee terms. So these are some of the challenges in front of India. Moving ahead, what the government is doing, what are the different policies to boost the natural gas production in India. Basically, their upstream and exploration reforms are being done by the government in the form of HELP framework. HELP is hydrocarbon exploration and licensing policy. Previously, we had NELP, new exploration and licensing policy. Now that NELP new was new in that time. अब वो old हो चुका है. So the new policy right now is HELP, hydrocarbon exploration and licensing policy. So if you get these type of terms in prelims, remember always this. This can be a kind of trap in exam. NELP, new exploration policy, is older one, and the newer one, actually newer one, is HELP. Well, basically what they did now in this HELP policy, government said that this is one block, let's say Bombay High. You take the entire block, do exploration, research, processing, and everything, and whatever hydrocarbon you get, coal, crude oil, natural gas, anything, you keep all of that. Just share some revenue with the government. Earlier, what government used to did, they've given you one block and they have given you permission only for, let's say, natural gas. If crude oil comes out there, you will not get anything. So the, let's say a company, let's say Reliance, they explores a particular area, they make all the facilities there, they do research and development work, they put in all the hard work, and if instead of natural gas, crude oil comes out from there, they are not given anything. So the private pays, they were not incentivized to do research and development in such blocks. Now entire block is given to them. So they can easily go there, work there independently, do research and development and extract minerals and they'll share some part with the government also. Okay, so this is basically your health policy. Then petroleum, natural and natural gas rules streamlines approval within 180-day limit, basically ease of doing business in these kind of projects. Then pricing and marketing framework granted producers the liberty to sell specific portion of new output through authorized gas exchange.
Sir, you are not audible. No, sir. Still not audible, sir.
Now I must be audible to you guys.
Yes, sir.
So battery of my headphone got discharged. So I changed it. Fine. So I'll be again sharing the screen. So we were here. Hmm. So I've told you regarding health policy of government, and now other ease of doing business steps government is taking. Then just like you have National Stock Exchange, Bombay Stock Exchange, where trading of shares of different companies happens. Similarly, we have Indian Energy Exchange (IEX), where the trading of electricity happens. Now the government has allowed these producers to extract this natural gas and sell this natural gas on, let's say, your Indian Energy Exchange, or let's say MCX, multi commodity exchange, in these platforms. So again, it becomes more lucrative for private players to put in money, to put in efforts into extraction and exploration of these resources. Yeah, and then discovered small fields policy. They are auctions are being held for small and unused gas fields to private players, so that whosoever is the highest bidder, you come and do the work here under the health policy. Apart from this, a lot of infrastructure and market integration is being done, like unified pipeline tariff, like one nation, one grid, and one tariff. So basically, they are saying that in the entire country, you'll have similar tariff to create uniformity. Then a lot of city gas distribution is happening through companies like IGL, Indraprasth Gas Limited, or MGL, yeah, Adani Total Gas. And these companies are selling uh, gas in the cities. Like in Delhi, you have IGL. In Gujarat region, you have Adani Total Gas. And then compressed biogas is also being promoted alternative domestic gas through blending mandates and plant sponsoring initiative like SAT8. SAT8 is basically a scheme for alternative fuels for transportation to reduce import on crude oil. These are some of the steps government is taking. You need not remember all of them. Even if you write three, four, that is good enough. Okay. Moving ahead, coming to the nuclear energy. Now, nuclear is the another important topic this time, which can be part of your exam. As let's take a minute's break. I'll have some water. I'm intentionally speaking from 1.5 hour. So we'll take a quick 1 or 2 minutes break. I'll have some water and I'll come back. Fine. So let's continue with the nuclear energy. Now, our government is putting a lot of focus on nuclear energy these days. We have increased. We have taken an ambitious target of 100 gigawatt by 2047. There is an entire global resurgence in when it comes to nuclear power these days. Why? Because see, when the Chernobyl event happened, where in Chernobyl there was a large nuclear power plant, and because of some accident, that plant got melted, the nuclear reactor got melted, and the nuclear radioactivity spread to the entire town, and lakhs of people died there in Chernobyl because of radioactivity, and a lot of area became infertile. People migrated, the entire town became a ghost town. People migrated out of Chernobyl. So that created a danger in everybody's mind. So now nobody wants nuclear power plant in their vicinity because they have fear that something wrong may happen. But because this is a reliable and clean source of fuel, again the world is seeing a resurgence in nuclear power. Why clean? Because no pollution is created. And how reliable? See, in case of solar, it can produce electricity only during the daytime. In nighttime, we cannot have solar energy. When it comes to wind, only when we have wind blowing, they can produce electricity. And at that time, when the wind is not blowing, they cannot produce electricity. But in nuclear, it can produce electricity 24/7. So that's why it is a reliable source. And some areas, let's say, for example, your data centers, they require 24/7 electricity. So now government, instead of having large nuclear power plants, government is now focusing on small modular reactors. These small modular reactors are the one which are having capacity of less than 300 megawatt of electricity generation. Now you will read all this when it comes to your science section. These small modular reactors, three-stage nuclear reactors of India, they are part of your science labs. Yeah. So India right now has 23 operational reactors at different locations, which right now contributes just over 3% of the total electricity generation in India. The Nanor atomic power plant in UP, Rawat Bhata plant in Rajasthan, Kakrapar in Gujarat, Tarapur in Maharashtra, Kaiga in Karnataka, Kudankulam in Tamil Nadu are some of the famous nuclear power plants or reactors. ठीक है क्या benefit है as we have seen clean source reliable and continuous power and avoids massive CO2 emission so good for environment good for reliability. Moving ahead, what are the challenges in nuclear energy generation? See, there is a lack of independent regulator in India. The Atomic Energy Regulatory Board, it operates under Department of Atomic Energy, which raises concerns about its autonomy and transparent oversight. This Department of Atomic Energy is directly under the Prime Minister's office. So, and this regulatory is working under the department. So, a regulator has to be independent to work fairly. But when it is, let's say, working under a department, they will always favor, in case of any dispute between private party and government, they will favor government only. Nuclear waste management. There is a no clear solution for long-term nuclear waste management. Right now, to what we are doing, we are temporarily storing nuclear waste in cooling pools and as dry cracks. But we need to come up with a long-term solution of radioactive waste. Then there is a high capital cost, both initially also and then maintaining also. You have limited domestic fuel. Now we have a lot of thorium reserves in India, but uranium is the primary raw material required in nuclear energy generation. So uranium reserves are not much in India. We largely rely on import of uranium. So these are some of the challenges in nuclear energy. And your let's say Australia is having the largest known reserves of uranium, but Australia is among the top producers of uranium. Then comes Canada, iron, aluminium. Hello, the connection got disrupted. I'll be again sharing my screen. Fine. Can you guys hear me?
Yes, sir.
Fine. And screen is also visible?
Yes, sir.
Fine. So I was discussing that Australia is having the largest known reserves of uranium, but Australia is not the largest producer of uranium. In other minerals, let's say iron, aluminium, and bauxite, bauxite is for aluminium, copper, Australia is among the top producers, but when it comes to uranium, there is a dichotomy. Australia is the largest, no, having known reserves, but not the largest producer. Who is the largest producer of uranium? Kazakhstan. It's the world leader, which supplies 39% of uranium. Then comes Canada, supplying 24% of the uranium. And then Namibia. Namibia produces roughly 12% of uranium. Australia produces just 8% of uranium, despite having 28% of the reserves. These are the major uranium suppliers in the world. Now, in India, we also have uranium and thorium reserves. The availability of raw material for the generation of nuclear energy in India. Uranium is basically deposits are primarily found in Singhbhum belt of Jharkhand, in Jadugoda mines. In the Singhbhum mines, Jadugoda mines, we have uranium deposits. We have in Andhra Pradesh, Tumalapalle region, we have Kadapa mines, where we have, or the Kadapa basin, where we have uranium deposits. In Meghalaya also, Domia Siat region in Meghalaya, we have uranium mines, and some in Rohil region of Rajasthan also. Then comes thorium. In the monazite sand of Kerala, Tamil Nadu, Odisha, Andhra Pradesh, most of the eastern coast, we have this monazite sand which contains thorium. So we have enough abundant reserves of thorium in the coastline. But again, uranium is more important when it comes to the nuclear energy generation. Changing energy was about the global distribution. No, it was not about global distribution. It was about global production. More about production. That who produces how much. When it comes to distribution, yes, these countries also have reserves, but Australia has the largest reserve. So basically, the kind of both distribution and production are shown here, but majorly production. Okay, Pankudi. Moving ahead. Now, Shakti Act has been created recently, passed by the Parliament. This is sustainable harnessing and advancement of nuclear energy for transforming India. You might have studied this in current affairs. The Act consolidates and modernizes India's nuclear legal framework. So it brings in all the different acts together. It enables a limited private participation in the nuclear sector under regulatory oversight. Earlier, private players were not allowed in this area in nuclear energy, but now private players are being allowed in this area also. It strengthens the statutory regulation granted by granting statutory recognition to Atomic Energy Regulatory Board. Now, earlier this board was working under Department of Atomic Energy. Now also it is working under that department, but at least they have a statute backing this particular authority, which gives them more power to work independently. So it supports India's clean energy transition and long-term objective of achieving 100 gigawatt of nuclear energy capacity by 2047. So this is your Shanti Act. Bhagyalakshmi says currently with Australia also that deal was signed. Is that different, sir? No, multiple deals are being signed again and again by the government by different countries. With Australia, we are signing deals for uranium supply and for other elements also. I think for coal also a deal is being signed with Australia. Adani will be doing a lot of mining works in Australia in these regards. So these are for this purpose only, for generating 100 gigawatts of electricity by nuclear by for small modular reactors. We are partnering with different countries like USA, France, Russia for nuclear reactors also. So multiple deals are being done with different countries. Now coming to the last topic of today's discussion, that is industries. Now, first of all, we should know the classification of industries. It can be done on multiple bases. The industries can be based upon sign. It can be a small cottage industry in a rural area, or they can be MSME, small scale, medium scale industries, or large scale industries in urban areas. Then, based upon raw material, what kind of input you put in that industry, it can be agro-based industry. Now, um, give me a quick example of agro-based industry. Any one of you? A real life example of agro-based industry. Sugar mills, yes, sugar mills are agro-based industry. Ashirwad Atta, made by ITC company, that is, yes, agro-based industry. Ketchup industry, completely fine. Entire processing industry. Then you have mineral-based industry like metallic, non-metallic. You have Hindalco, Tata Steel. These are mineral-based industries. You have chemical-based industries like Tata Chemicals again, Vinati Organics, Deepak Nitrate. These companies. Then you have industries based on forest products, like your paper mills, JK Paper, Classmates, again by ITC, the industry based upon forest products. For animal feed, animal based industry, you have, let's say, poultry farms, poultry industries, meat industry. Clear? Then, on the basis of what kind of product they produce, one is the basic product, like the intermediate products. For example, the machines, the molds, dyes, machines are created, which are further used in production of other goods. Then there are certain goods which are directly produced for consumption. Let's say biscuits. These are consumer goods. Air conditions. These are consumer goods. Then, based upon ownership, you have public sector by government owned, private sector, private owned, joint ownership between both public and private. These are different classification of industry. I hope this is clear. Moving ahead, we should know what are footloose industries. Footloose industries are also mentioned in your NCRTs, but they are given very briefly. These footloose industries are important in any developed country. In most of the cities, you have footloose industries, which are not dependent upon any location for raw material. These industries, they can get raw material from anywhere. They can set a factory everywhere, anywhere, provided you have labor and money, or they need connectivity, housing, all this for establishment, but they do not require specific raw material. So the footloose industry can be located anywhere without being affected by resources, land, labor, capital. So those areas where all these are easily available, anywhere this can be established. What are the key characteristics? Location flexibility. For example, let's say a sugar mill can be located in areas close to sugar fields. Otherwise, the transportation of sugar mill, a lot of sucrose content will be evaporated from sugarcane in transportation alone. Your textile industries will be set up close to cotton producing regions. Your, let's say, jute textile mill will be close to, let's say, Brahmaputra or Ganga basin. ठीक है? Similarly, your food processing tea factory will be close to tea plantations of, let's say, Darjeeling. But footloose can be established anywhere. They have fixed cost irrespective of location. Their raw material are small, light, and easily transportable. They have skilled labor workers, which are skilled. These type of workers are required. Output is generally lightweight and high value products. And their environmental impact is generally very less. They have low carbon footprint and they're generally non-polluting. And preferred locations are largely your peaceful areas, which are cost-effective areas with good connectivity and transportation. Examples are your diamond industry in Surat, computer chip making, let's say in Gujarat and Assam, your mobile manufacturing in coastal areas, or you can say in cities of Tamil Nadu. A lot of mobile manufacturing and export is done from there. Honey processing, largely honey processing has now become agro-based industry. A lot of honeybee, bee cultivation is happening in different areas now. What is the importance of these food industry? They create a lot of jobs and skill enhancement. They create skilled jobs. They lead to economic diversification, regional balance. People move away from agriculture. Still, 55% of the population is directly dependent upon agriculture. They move from agriculture to these industries. Then you have a lot of technology and innovation coming into India because of this. These food industry, they promote R&D. A lot of these industries, they are inspired from the developed world. And then you have a lot of investment and economic growth happening because of these industries. Because when one industry is deployed, more industries come in the vicinity. Yeah. Then we come to next topic, that is industrial regions of India, where these industries are located. See the pink or the, let's say, the brown, these pink highlights. These are the major industrial regions of India. This is in Gujarat, you have Ahmedabad-based industrial region around Ahmedabad. In this, you have Mumbai Pune industrial region. Here you have Bangalore Coimbatore industrial region. You have Kollam Tirunelveli industrial region. Visakhapatnam Guntur, mostly your heavy metal industries here. Your Chota Nagpur, mining based industries. Hooghly Kolkata region, a lot of textile industries. You have Delhi, Meerut, Gurgaon, Delhi NCR region. Again, a lot of service based industries are here. Then you have small minor industrial regions highlighted in the blue, and your industrial districts in different areas like Lucknow, Kanpur, and UP are industrial districts. What are the characteristics of these industrial regions within India? There are concentration of industries. These cores have been developed where a lot of industries come together. And once industries start coming together, it becomes a natural magnet. More and more industries then concentrate on that region. Why? Because they have skilled labor available there, they have better connectivity, they have better infrastructure, they have government support, they have export opportunities from these areas. Right? Resource-based localization happens. Some of these are having proximity to raw material. For example, your Dhanbad and Bokaro, um, your cotton textile industries in Mumbai Pune region. Okay, then they are close to urban agglomerations like this Kolkata region, Delhi NCR region, Mumbai region. A lot of well-connected transportation is there. See why the government has chosen Ahmedabad Mumbai bullet train project. Now, can you understand this from geographical perspective? Ahmedabad is an industrial region. Mumbai is an industrial region. These industrial regions should have good connectivity. So more and more trade happens. Now, what will happen? This pink highlight after 10 years, this will cover this entire area. Continuous urbanization, continuous industrial regions will develop along with this region. That's why the connectivity between industrial regions is important. And now you can understand why Ahmedabad to Mumbai has been chosen as the area for this bullet train connectivity. Similarly, Delhi Mumbai Industrial Corridor is being developed, again connecting two industrial hubs so that the movement connectivity becomes very well. Similarly, labor force availability, as I've told you. Fine, these are some of the characteristics of these industrial clusters. Then we come to another important concept that is called your industrial corridors. Okay, industrial corridors in India. Now, corridors are regions of continuous development. See, they connect major industrial regions to improve transport and logistic infrastructure, like Delhi Mumbai Industrial Corridor, this first one. Okay, these foster economic integration and addresses key spatial and developmental challenges. When these two areas are well connected, more economic integration happens, more trade happens, more connectivity leads to higher easy transport of goods. Clear? Now, if you order something from e-commerce website, let's say Amazon, sometimes it shows that your parcel is coming from Bangalore, a parcel is coming from Bombay, or somebody from Bombay they are ordering, parcel comes from Delhi. So this connectivity through road, railway, airport, all this is important for trade to happen. Now, along this Delhi Mumbai Industrial Corridor, dedicated freight corridor is also being developed. Now, what is dedicated freight corridor? Freight means a railway track which transports goods. Special railway tracks are being created from Delhi to Mumbai, which will just carry goods, not people. People will travel on the same old railway tracks, new railway tracks, which will very quickly transport goods from, and let's say, New Delhi to Bombay. And now imagine if we have to export something from India, from Jawaharlal Nehru Port of Bombay, which is the largest port, it takes a long route or uh, you can say a lot of time to transfer from first it goes from Delhi to Mumbai, then it is being exported. But with the availability of better road connectivity, better dedicated freight corridors, and these dedicated freight corridors will they'll carry double decker trains, multiple you can say loads they will carry containers. So very quickly goods will be transported to port and then it can be exported quickly. This is how we have to compete with China. China has so good infrastructure that let's say if you order something in a inland city of China, within 3 days it will be exported from there. So we have to create similar kind of infrastructure for to gain control over exports. What are the benefits of these industrial corridors? Regional economic integration, better connects different economies, improved connectivity, faster mobility, enhance export competitiveness, balance regional development. So all the rural areas also which are lying in between, they will also get developed. Continuous urbanization. In geographical terms, it is called conurbation. Conurbation is the term for continuous urbanization. Let's say Delhi Chandigarh highway, which is there, the GT Canal Road there, that is developing one conurbation. Mumbai Pune is developing another conurbation where there is continuous development along the highway. Okay, and more jobs will be created. For example, the Delhi Mumbai Industrial Corridor, it is expected to create 100 million jobs by 2040. Similarly, you have Ahmedabad, Amritsar, Kolkata, dedicated industrial corridor. Along with this, also your Eastern dedicated freight corridor is being created from Punjab, Ludhiana, Amritsar, Patiala. These are good industrial manufacturing zones. From here, again, a dedicated eastern. From Delhi, Mumbai, we have western dedicated freight corridor. From Mysore, Kolkata, we have eastern dedicated freight corridor for movement of goods will happen. Similarly, you have Delhi, Nagpur dedicated industrial corridor. You have Mumbai, Bangalore industrial corridor, and different industrial corridor. At least you should know two, three of them, so that whenever a question regarding industries, question regarding economy, question regarding export, question regarding regional development, question regarding manufacturing will come, you can use these kind of maps. You can draw these labels in your answers, and these things will fetch you half to 1 marks extra in your answers. Clear? So one more thing which we should know, the difference between these industrial corridors and special economic zones. See, China's development happened because of the six special economic zones they have created. Now they have created very large, huge size, the entire city size special economic zones. These special economic zones you will study in economics, they are treated as a foreign territory when it comes to trade. So anything which is imported into this area, they do not have to be any import duty. When the goods move out from these special economic zones to mainland, then they give import duty. So that is a separate concept. But what happens? India does not have very large special economic zones, but we have small, many economic zones. China has six large special economic zones. We have more than 250 smaller special economic zones. But it has not been as productive for India. Why we opted for so many smaller special economic zones? To have regional economic development. But somehow they have not worked really well. Whereas industrial corridors are the one which are based broad industrial development and job creation across large area happens. So your industrial corridor will happen right from Delhi to Bombay. But special economic zones they promote export and attract FDI and tax incentive in a smaller places. So these are smaller duty-free zones for specific industries and especially for export. For example, the Kandla port of Gujarat. Close to that Kandla and let's say Mundra port, you have Mundra Special Economic Zone. Okay, this is largely for promotion of export. But here, large-scale projects spanning multiple states take place in industrial corridors. Like Delhi Mumbai Industrial Corridor covers roughly 1,500 kilometers across six states. High-speed transport, logistical, smart cities will be created along with it. And here, government provides basic infrastructure for export-oriented industries. Industries come in and plug into that infrastructure, and they start working. For example, government provides road, electricity, warehousing, all these things. And this will be managed by National Industrial Corridor Development and Implementation Trust, here with state partnership. And these are governed by the Special Economic Zone Act of 2005 and other your development commissions. So this is the basic difference. So industrial corridors are large, huge projects. Special economic zones are dedicated for export and these are smaller areas. Moving ahead, along this industrial corridor, you have defense industrial corridors also coming up for defense production. Now, defense production is also gaining traction in India. In last 14 years, we have increased our defense production four times and roughly around more than 1.5 lakh crore of defense products we are now creating on our own. India, along with Saudi Arabia, were among the top defense importers in the world. We import defense products from Russia, France, UK, USA, most of these developed countries. And we are a major, you can say, defense consumer. Our defense budget is more than 7 lakh crore. Out of the entire budget of India, 14% of the budget is spent on defense. So such huge amount is spent. And a major portion goes on the import of defense products. Now government is focusing on defense production within the country. So two dedicated defense industrial corridors are being proposed in India, one in UP and one in Tamil Nadu. These will be the six cities, Aligarh, Agra, Lucknow, Kanpur, Jhansi, and Chitrakoot. These six cities will produce, specialize in different kind of defense production. For example, let's say your Agra will specialize in grenade manufacturing. Lucknow will specialize in missile manufacturing. You know, different technologies. Let's say your Kanpur will specialize in armored vehicles manufacturing. So a better connect through highways, expressways, better connectivity will be there. So a synergy will create. A hub for defense production will be created in these places. Similarly, in Tamil Nadu, you have Chennai, Hosur, Salem, Coimbatore, and Tiruchirappalli. These areas again will need to create a hub of defense production. And from Tamil Nadu, a lot of export can also done easily because three major, you can say, ports are available in Tamil Nadu. You have Tuticorin Port, Chennai Port, and Ennore Port. Yeah. So these are also defense industrial corridors are also part of larger industrial corridor theme. So whenever questions, as I told you, regarding economy, defense production, export, manufacturing, industries, regional development, employment, whatever comes, you can use these everywhere. Fine. So apart from this, some tier two and tier three cities in India are also emerging as industrial clusters. For example, Indore in Madhya Pradesh, they are emerging in light engineering, pharmaceutical, and ITs. Coimbatore in Tamil Nadu, which is also part of dedicated defense corridor, it is being emerged as a general engineering and global capability centers. Now, global capability centers are the basically IT headquarters of different companies. Let's say an American company, earlier they used to outsource work to Indian IT services, company like TCS Infosys. Now what they does, they set up their own office in India. They hire few software engineers and make it as a global capability center. All their IT services, software operations are then run from India because India has good software engineering talent. So these are GCCs, called GCCs. They are being developed in Coimbatore. They are being developed in Bangalore, Gurugram, Delhi. Surat is emerging as a textile hub, diamond hub. Nagpur is emerging as a multimodal industrial cargo hub. Nagpur lies somewhere in center, so a lot of connectivity is being created. Ludhiana again, a lot of manufacturing happens in Ludhiana: light engineering, bicycle manufacturing, auto components manufacturing. In Vadodara and Rajkot in Gurugram, chemical manufacturing, heavy machinery, diesel engine, and specialized manufacturing. And Lucknow, Kanpur for textile manufacturing, defense manufacturing. Within textile, you have a lot of leather industries in Lucknow, Kanpur. You have woolen and cotton textile industries. So these are also emerging. You can make a India map and show 4, 5 of these tier two, tier three cities which are emerging as industrial clusters. All these things, locating them instead of just writing, locating them on map. These fetch you extra marks in your main answers. Clear? So with this, we come to end to today's session. Now, if you have any doubt, you may ask, or you guys are free from my side. So, what is the source of global critical mineral production charts 2019 data? Uh, these sources are largely your Statista, Bloomberg. What I have searched is largely this image is generated from the data which I got from Statista, Bloomberg, and those sites. Okay, Bhuvnesh says thank you. Kushi says thank you. You guys can also look for the latest data. If you get somewhere 2019, 2025, 26 data, or let's say in your monthly current affair magazines, you might get this data till the time your prelims or mains comes next year. Thanks, Anurag, Khushi, Pankudi, Prabhati, all of you. Thank you, guys. Welcome, welcome, guys. All the best from my side. If you have any doubt, you can any day come to the mentors room on the fourth floor in new building. We are all available, and all the best to all of you. Make sure you guys give your MSP tests on time and do your revision. I'll see you again. All the best,
So,
guys. Yes.
sir, likewise, currently,
Hmm?
the demand for E20, I mean,
Uh,
the youth is demanding that we the clear petrol, मतलब कि the exact मतलब what is the petrol without the ethanol blending was
hmm.
demanding because some of the vehicles are not capable for it.
Yes.
So, what should be the way forward, keeping in mind the current situation?
See, way forward, we have to write a balanced way forward where we can talk about that government should do more pilot projects on this before implementing it nationwide. I remember there was a news where government in Supreme Court, the government representatives, they said that still pilot projects are going on. So we can write this kind of suggestions that better research and clarity can be given regarding the usage of E20 without first rolling out it in the entire country. So, see, the people have the right to get clarity over E20 fuel. Also, the government a lot of times cites example of Brazil. So we can make a small case study of Brazil and write how Brazil is also using E10, E20 fuel, but they are also providing at the same time 100% petrol, E10, E20 fuel in every petrol pump. They have different nozzles for pure petrol, E10 and E20. But in India, what one thing wrong is happening that we are not giving options. The government is not giving options to people to choose among the fuel. So we can give this kind of case studies as an example. So we can learn from the Brazil model where we can provide different type of fuels. Or push towards electric vehicle can be a way forward. That पंगा ही खत्म करते हैं E20 वगैरह का कि why not we move towards electric vehicle, because ethanol is also produced by a lot of water gets wasted in producing ethanol. First, understand that for production of 1 kg of sugarcane, around 1500 to 2000 liters of water is used. Then a lot of sugarcane is used for producing ethanol. So it does waste a lot of water also. And India is a water scarce country. So we can write these things also.
Okay, sir. Thank you so much.
Welcome, Khushi. Okay, guys. Then I think 2G ethanol made from biomass instead of. Yes, you can talk about 2G ethanol made from biomass. We can also talk about ethanol made from genetic engineered bacteria or other things. They can be used, but they can be part of your suggestion. They are part of government's biofuel program, but I think not much commercial, you can say, development is happening on that regards. Mostly it is in experimental phase. So, okay, guys. Okay, welcome. Bye bye. See you again.